So the section for today is on optimization, which are extremely interesting problems using calculus. So I'll do a few problems, and if you have questions, please just interrupt and ask. This is all really very useful material. So problems, this is example 1. So we have some material for building a box. And let's say we have 108 square inches of material to build the box. And it's going to be a box with an open top. So there'll be 4 sides and a base. And we're told we want to build a box with a square base, no top, that holds as much as possible. So we want to maximize the volume. So if the base is square, let's say it's x by x inches, and let's say the height is h. So x equals the side of the square base, h is the height. So the volume of this box is the area of the base, x squared, times the height. And we want to maximize that. Well, what does it mean to maximize that? We only have 108 square inches of material. So the area, the surface area of the box is what? Well, we have a base, which is a square of side x, so it has area x squared. Each side of the box has base x and height h. It's a rectangle. So the area of each side is hx, and there are 4 sides. And we're going to use all the material we have, 108 square inches. So we have this constraint that x squared plus 4hx equals 108. And subject to this constraint, we want to choose the dimensions that maximize the volume. Well, from this condition, if we want, we can solve for h. This says that 4hx equals 108 minus x squared. So x is 108 minus x squared over 4h. Sorry, let me solve for h. H is 108 minus x squared over 4x. So v, which is x squared h, is going to be 108 minus x squared over 4x times x squared. This is x squared h. And one of the x's cancels. 108 over 4 was 27. So this is equal to 27x minus 1/4 x cubed. So as a function of x, this is the volume. And we want to maximize this function. So how do we find a maximum? Take dv dx. That's 27 minus 4x squared, 4 times 3x squared. So that's 27 minus 12x squared. Oops, sorry. Let me do this right. I differentiate that, I get 27 minus the derivative of x cubed, 3x squared over 4. And the critical number is when this is equal to 0. So 3/4 x squared equals 27. X squared equals 4 times 27 over 3, which is 4 times 9 or 36, which means x is equal to 6. If we were to take the second derivative, this would be minus 3x squared, 3 times 2x over 4, or minus 3/2 x. When x is 6, this is negative. That means this is a maximum. And so we let x squared equal 6. So the base has side 6, and h is 108 minus 6 squared, 36, over 24. That's equal to 72 over 24, or 3. So to find the box of maximum volume, it has height 3 and base 6. And you can check, each side has area 18, 4 sides. 4 times 18 is 72. The base is area 36. It adds up to 108 exactly. So we've used up all of our building material and we've maximized the volume of the box. So this is a nice example of an optimization problem. Okay. Any questions about that? Example 2 in the text is to find the minimum distance from a point on the parabola y equals 4 minus x squared to the point on the y-axis 0, 2. So if we sketch this parabola, it's 4 at 0, it's 3 at plus or minus 1, it's 0 at plus or minus 2. This is my parabola. Here is the point 0, 2. And if I take any point on the parabola, there's a certain distance d from the point to 0, 2. And we want to find the point on the parabola that's closest to 0, 2. Or there's a certain symmetry here. If there's whatever one point is, the symmetric point, the point symmetric with respect to the y-axis, we'll also have the same distance there. We want to find the points on the parabola closest to 0, 2. So for any x, this has coordinates x, y, but y is 4 minus x squared. And this distance, d, is the distance from this point to this point. So the distance is the square root of the difference between the x and the y coordinates. X minus 0 squared plus 4 minus x squared minus 2 squared. That's the square root of x squared plus 2 minus x squared squared. That's the square root of x squared plus 4 minus 4x squared plus x to the 4th. That's the square root of x cubed minus 3x squared plus 4. So for any x, this is the distance to the point 0, 2. Now, if we want to simplify our work a little bit, the square root of a number is smallest when what's inside the square root is smallest. So it's enough to minimize just the function f of x equal to x cubed minus 3x squared plus 4. First derivative is 3x squared minus 6x. That's 3x times x minus 2. That equals 0. And x equal 2. Let's see. X cubed minus 3x plus 4. Oh, this is x to the 4th. X to the 4th. So this is 4x cubed minus 6x. That is, let me do this nicely. Four x times x squared minus 6 over 4 minus 3/2. That equals 0 when x equals 0, or plus or minus the square root of 3/2. See, what is the second derivative? Second derivative is 12x squared minus 6. So the second derivative at 0 is minus 6, which means we have a local maximum there. And the second derivative at plus or minus the square root of 3/2 is 12 times 3/2 minus 6 is 18 minus 6 is 12, which is positive. So plus or minus the square root of 3/2, these are local minima. That's what we want, a minimum, the closest, the smallest distance. So if we take the points plus or minus root 3/2 and 4 minus 3/2, 4 minus 3/2 is 5/2. These are the 2 points on the parabola that are closest to the point 0, 2. So here in our first problem, we were trying to maximize a volume. In this problem, we are trying to minimize a distance. Any questions about this? These are really very important problems to master. Let's look at example 4. So on the ground, "30 feet apart, we have 2 posts, and one of them is 12 feet high, and the other is 28 feet high. And we pick a point X between 0 and 30. And at that point X, oops, excuse me 1 second. Oh, sorry. So we have 2 poles, a 12-foot high pole, a 20-foot high pole, and they're 30 feet apart. If we take a point which is X units from, let's say, the left, from that point, we run wires to the tops of the poles. And so this has a certain distance, and this has a certain distance. And what we want to do is minimize how much wire we use. We want to minimize y plus z. So how do we do that? So of course, this distance is x, and this distance is 30 minus x. And we can find y and z just from the Pythagorean theorem. So for y, we know that's the hypotenuse of this right triangle. X squared plus 12 squared is y squared. So y is the square root of x squared plus 144. And in this right triangle, 30 minus x squared plus 28 squared is z squared. So z is the square root of this plus this. Let's see, 30 minus x squared is 900 minus 60x plus x squared plus 28 squared. That's 784. So this is the square root of x squared minus 60x plus 1,684. So the total distance, which is a function of x, that's y plus z, is the square root of x squared plus 144 plus the square root of this expression. So the book calls this W for wire. So we have to differentiate because we want to minimize this. So we want to find the critical numbers dy dx. So this is 1 over, so we differentiate this, we get 1 over, we get this to the 1/2. So it's 1/2 times the square root of x squared plus 144 times the derivative of x squared plus 144, which is 2x, plus the derivative of this, we get 2 over the square root of x squared plus 60x plus 1684 over the derivative of this, which is 2x minus 30. And these x's cancel. Sorry, 2x minus 60. And we can, so that's x 2 times x minus 30. And these 2's cancel. So this is x over the square root of x squared plus 144 plus x minus 30 over the square root of x squared plus 60x plus 1684. And we want that equal to 0. So we just have to solve this equation. X over the square root of x squared plus 144. Bring this to the other side, you get 30 minus x over the square root of x squared plus 60x plus 1684. And you have to solve that equation. And so you do some algebra, it's all done in the text, and you get two values for x equals 9 and minus 22.5. And you don't want a negative number, you want a positive number. So x equal 9 has to be the solution. Okay. Any questions about that? Let's do some other problems. Maybe I'll pick a couple from the homework. Oh, here's a nice problem. So this is number 3. Find two positive numbers, x positive and y positive, whose sum is s, some number s, and the product, that's called p, which is x times y, is a maximum. So how do we solve the problem? Well, x and y are related. Given x, y has to be equal to s minus x. So p, which is xy, is x times s minus x. That's sx minus x squared. So if I differentiate this, I get s minus 2x, which is 0 when x is equal to a half of s. And the second derivative is minus 1. So s over 2 is a relative maximum. So if you have two numbers that add up to s and you want to max the product, we choose x and y equal to s over 2. And then the product is s squared over 4. Oh, let's look at number 25. So we are going to construct a Norman window. A Norman window is a window with which looks like a rectangle with a semicircle on top of it. So this is the window. So if this width is x for the rectangular part, we call that y. This is x over 2. So this upper half is a semicircle whose radius is x over 2. And what is the perimeter of the window? You have a base x, two vertical sides of length y, plus half of the circumference of a circle of radius x over 2. Now the circumference of a circle is 2 pi r. So this circle, it's half of that. It'll be pi r, and the radius is x over 2. So this is equal to 1 plus pi over 2x plus 2y. That's the perimeter. And we're told that we can construct a Norman window where the total perimeter is 16 feet. And we want to maximize the area of the window. What is the area of the window? The area of the window is this rectangular part, which has area xy, and the semicircle. So the area of a circle of radius r is pi times the radius squared. The radius is x over 2. But this is a semicircle. It's only half of that. So it's a half. So our area is xy plus x squared pi over 2 times 4 over 8. But we have a condition on that relates x and y. This is the condition. We know that 2y is 16 minus 2 plus pi over 2 times x. So if you divide by 2, y is 8 minus 2 plus pi over 4 times x. So what we get for our area as a function of x is x times y. If you multiply y by x, you get 8x minus 2 plus pi over 4x squared plus pi over 8x squared. So this is 8x. And here what I have is x squared. I have minus a half x squared minus pi over 4 plus pi over 8 is minus pi over 8 x squared. So this is a formula for the area of the Norman window as a function of x. So again, let me just review how we did this. Norman window consists of a semicircle on top of a rectangle. This is all the window, it's all glass. And the perimeter is x, 2y, pi times the radius, pi x over 2, which is 1 plus pi over 2x plus 2 pi. And we're told that the total perimeter is 16 feet. So if you solve this equation, you can express y in terms of x. 2y is 16 minus, this is 1 plus pi over 2 is 2 plus pi over 2x. Divide by 2, we get this. And the total area is xy plus a half pi r squared, that's this. Plug in this value for y, you get 8x minus 2 plus pi over 4x squared plus pi over 8. This is minus pi over 4 plus pi over 8 is minus pi over 8 minus a half. This is the area. So the derivative is 8 minus 2 times this times x. So 8 minus, this is like a half plus pi over 8 times minus a half plus pi over 8. So that's minus 1 plus pi over 4x. And that equals 0 when x is equal to 8 over 1 plus pi over 4, which is 32 over 4 plus pi. And when x is equal to this, y is equal to 8 minus 2 plus pi over 4 times 32 over 4 plus pi. This is 8 minus 8 times 2 plus pi over 4 plus pi. That's 8 times 1 minus 2 plus pi over 4 plus pi. So this is 8. I have a 4 plus pi in the denominator. 4 plus pi minus 2 plus pi is 2. 8 times 2 is 16. So this is my value of y. And let's just sort of see. Let's just check the parameter. X plus 2y plus pi over 2x is 32 over 4 plus pi plus 2y, which is another 32 over 4 plus pi. plus pi over 2 times x. That's 16 pi over 4 plus pi. So that's 64 plus 16 pi over 4 plus pi. That's exactly 4. That's exactly 16. That's right. So this is the answer. Very nice. Any questions about this? Any homework problems you would like me to do? I'll do 1 or 2 more because these are kind of fun. Let's look at number 27. So a right triangle is, oops, sorry, excuse me 1 second. Yeah, number 27. A right triangle is formed in the first quadrant by the x and the y axes and a line through the point 1, 2. So there are lots of lines. This is the point 1, 2. There are lots of lines through the point 1, 2. And every such line determines a triangle. And we want to find the triangle of minimum area. Okay. So first we're asked to find the length of the hypotenuse. As a function of the point x, 0, where the line hits the y-axis, hits the x-axis rather, excuse me. So we have the point 1, 2. Pick a point on the positive x-axis, draw the line through that point and 1, 2, and let's say 0, y is where it hits the y-axis, and the hypotenuse has a certain length, L. We want to compute L as a function of x. So let's see. We have a line going through these 2 points. What's the slope of the line? It's equal to the rise 2 over the run as you go from, as you go from 1 to x, the line goes down -2, and the distance from 1 to x is x minus 1. So the slope of the line is -2 over x minus 1, or 2 over 1 minus x. And what is the equation of the line passing through the point 1, 2 with this slope? Let me write this as t is a function of s, so instead of x and y, because I'm using x here. So t is going to be the slope, 2 over 1 minus x. The line goes through the point 1, 2, s minus 1, plus 2. So this is the equation of the line where t is a function of s with slope 2 over 1 minus x and passing through the point 1, 2. So this is 2 over 1 minus xs plus 2 minus 2 over 1 minus x, which is 2 over 1 minus xs plus, this is 2 minus 2x minus 2 minus 2x over 1 minus x, or 2 over 1 minus x s plus 2x over x minus 1. So this is the point where this line intersects the y-axis, 2x over x minus 1. So this is just using the equation of a line. If you know the slope of the line, this line has slope 2 over x minus 1, or minus 2 over, 2 over x minus 1. Minus 2 over x minus 1, 2 over 1 minus x. So 2 over 1 minus x times s minus 1 plus 2. The intercept on the vertical axis will be 2 minus 2 over 1 minus x, which is 2 minus 2x minus 2 over 1 minus x, or minus 2x over 1 minus x, or plus 2x over x minus 1. So this point is 2x over x minus 1. And so L is the square root of x squared plus 2x over x minus 1 squared. So that is the length L of the hypotenuse as a function of x. And if we want to, and what is the area? A, it's the base times the height. It's a half the base x times the height, 2x over x minus 1. So x squared over x minus 1. That's the area of this triangle. It's a function of x. So a prime of x is x minus 1 squared, the derivative of the numerator times the denominator, minus the numerator times the derivative of the denominator. So 2x squared minus x squared is x squared minus 2x over x minus 1 squared. And that's equal to 0 when x equals 0 or 2. If you let x equal 2, something isn't kosher here. So let me go through the analysis again. I mean, if you look at this geometrically, you can see a lot of what's going to happen. here's the point 1, 2. Now, if you take a value of y just a little bit bigger than 2, you're going to get this triangle, and the area is half the base times the height. The height's a little bigger than 2, and as you get closer and closer to 2, this base gets bigger, so the area is going to go to infinity. And similarly, if you take a point x very close to 1 and draw this triangle, look at it this way, the height is a little bit bigger than 1, and the base gets bigger and bigger, and the area will also go to infinity. But somewhere in between, you're going to have a minimum. There should be a triangle of minimum area. As you come in, the area should decrease, and then it should increase again. So if you have the line through 1, 2, and this point is x, 0, and this point is 0, y, you can express y as a function of x or x as a function of y. So this line has slope as you go from 1 to x. X minus 1 is the run, and the rise is from -2 down, is from 2 down to 0 is -2. So it's -2 over x minus 1, or 2 over 1 minus x. So that's the slope of this line. And the equation of the line passing through the point 1, 2 with slope 2 over 1 minus x is t equals 2 over 1 minus x, s minus 1 plus 2. And when s equals 0, t, which is this vertical intercept, is -2 over 1 minus x plus 2, or 2 plus 2 over x minus 1, or 2 times x minus 1 plus 2 over x minus 1, or 2x over x minus 1. So this y-intercept, y is equal to 2x over x minus 1. So the area, which is a half the base times the height, is a half x times the height, which is 2x over x minus 1. So that's x squared over x minus 1. Oops, is that right? What did I do wrong before? No, that's exactly right. That's the area. It's a function of x. A of x. So the derivative is x minus 1 squared. It's derivative of the numerator times the denominator minus the numerator times the derivative of the denominator. So this is 2x squared minus x squared minus 2x over x minus 1 squared, or x times x minus 2 times x minus 1 squared. And this equals 0 when x equals 0 or x equal 2. Oh, this is okay. I just looked at it wrong before. And x equal 2 is going to be the minimum. And when x is equal to 2, y is equal to 2x 4 over 1, which is 4. So this triangle passing through the point 1, 2 will be the triangle of minimum area for this problem. Okay. Any questions about this? Or any other problems you would like me to go over? I'm happy to. If not, there's an office hour tomorrow in the evening for people who work during the day, and I'll also have an office hour on Friday morning for people who don't work during the day, if you have questions. Okay. Anything before we stop? No? Okay. Have a good weekend, all.